This demonstration's meant to illustrate how moving electrons can be affected in their path by a magnetic field. So this is a vacuum tube, and if we come in a little bit closer and take a look at it, you can see that it's just a tube of glass, and right now it's evacuated, so there's almost no air in there. There's almost nothing. Very, very low pressure, low number of molecules. But if you take a look at it, you can see there's a metal plate, and that metal plate over here has a little slit in it. But the important thing is that it's sort of sitting at an angle, and the front of that plate is coated with what's called a phosphorescent material, which if an electron strikes it, it glows green, as I'll show you in a minute. And so the way this is going to work is this will be connected to a high voltage source, kind of like neon lights are. And that high voltage source is this little device over here. It just generates a very high voltage. It's connected. And on this end of the tube over here is a little plate. You can see it from the back. But that little plate right there is going to get so excited by the voltage that electrons are going to, we say they just sort of boil off or ejected from the surface. And they're going to fly away from that plate, and they're actually trying to make their way over to the other side, which is this little wire here that's connected to the ground. And the idea is that there's a little slit. You can see that right here in that plate that's in the middle, and that's only going to let the electrons that are traveling in a straight line through that slit to make it across to the other side. And the thing is, they're going to have trouble making it all the way across because the way this thing is angled, when they come through, some of the electrons are going to travel through and they're going to land on the surface of that plate and cause it to glow. And we can actually watch the path of the electrons as they travel through that near vacuum. So let's fire this up. Step back a little bit. And I'm going to put this camera into a stand. So I'm going to turn on the high voltage. And I need to turn down the exposure on the camera. So zoom in. That noise that you hear, that's just that high voltage generator. If you ever put your ear next to a neon light, it kind of makes a crackling noise as well. And then I have a bar magnet here. I'm sort of holding it up. You can see it. And you can already see I've bent that path of the electrons. And so let me show you what happens when I move the bar magnet in front of and behind the electron beam. As the bar magnet moves, you can see I'm deflecting the electron beam up and down. And so the north pole of a magnet moves the electron beam in one direction, and the south pole moves it in the other direction. And so we can cause a beam of electrons to be deflected in any direction that we want just by making an alternating magnetic field, or just even applying a steady magnetic field where I can cause a beam of electrons to curve in whatever direction. So I'm going to turn the lights down completely. See if I can make this a little bit more dramatic. So let's take that bar magnet. There I am. You can move it the other direction. If I do it over here, I can deflect it even more. So I think you can see that a magnetic field can have an influence on electrons, things that have charge. And as I'll show you in the next part here, that is sort of the way old TVs, when they had TV tubes before flat screens, this was called a cathode ray tube, and that's how, in part, how we were able to generate an image. So this is a different kind of tube, very similar to the last one, but shaped a little bit differently. And again, I'm sending high voltage between two terminals on the top right and the bottom right, and electrons are streaming through, and as they hit gas particles in there, they emit light. So we can kind of track the electron beam in this way as well. But this is not the interesting thing about this tube. I need to shut the power off and turn the lights on to show you. So we're going to look at the tube in this orientation. Ooh, that's hot. And if you look at it like that, and I turn the brightness down a little bit so you can see what the heck's going on. This is actually what's called a cathode ray tube. And in the early days, before they knew what electrons were, they had built these things and they called them cathode rays. So if I turn this up, and I turn the lights off, now we're going to adjust the shutter. So you're kind of looking right down the center of this thing. And want to show you, let's see if we should be able to see, I can deflect that beam with a magnet again. So do we notice anything? You can see right now you can't really see me holding the magnet, but I'm moving the magnet around. You can see the beam is deflecting inside there. It's kind of showing up pretty well. But this tube has one other interesting little aspect to it. And that is, it's got a little object you can put in the path of the electrons to show that they travel in a straight line. I just need to flip that up. So let me see if I can get that in there. There's a little metal cross-shaped thing. It's what we call a Maltese cross. Anyway, that's in the beam of the electrons, and so if I look at the side of this, the electrons are going to come from back here. Most of them are making their way down to the ground down here, but some of them are just traveling in a straight line through. And in theory, if the electrons are traveling in a straight line, if they are particles, and particles travel in a straight line, that cross that's in the way should cast a shadow in the electron beam. So let's bring that in a little bit. And I'll turn the lights out. Turn the power on. And you can see that shadow. How do I know it's a shadow? Well, watch when I bring the magnet next to it. You can see the shadow is being deflected in different directions. You can see that right behind that cross shape. And so I'm actually going to look at it a little bit more from an angle. See if we can get this zoomed in. So there you have a better view of the shadow, and I should be able to move that shadow around with a magnet. So what I'm doing is deflecting the beam so that the shadow of that object that's in there, that cross-shaped object, lands on different parts of the screen. I'm actually making all sorts of weird distortions to it as well. And so, how do you make an old-style TV screen? You set up something like this, except on the front of the screen here, in the front of the tube, you put a phosphorescent coating like we saw in the last device. And you use a magnet to deflect the electron beam left and right, which I'm trying to do, or up and down. by adjusting the magnetic field, and it will just scan across the front of that. And eventually, if you adjust the magnet and the intensity of the beam, you can generate an image. So this shows us that electrons are particles that travel in straight line, and also that they can be influenced, importantly, by magnetic fields. So there's no reason I shouldn't be able to make my own little vacuum tube that can generate a stream of electrons, and so that's what I did. And what I've got here is just a glass tube, and we're going to hook it up to a vacuum pump. But you can follow that black tube. There's a vacuum pump. Some guy who wandered in off the street. And what we're going to do is evacuate this tube. Now that vacuum pump isn't going to make a perfect vacuum. And when the vacuum pump is on, it's going to get most of the air out of the tube, but not all of it. And that is kind of a key for how this is going to work, and that there's still some air molecules left inside the tube. And the other thing we need to do is to generate a high voltage so that we can get the electrons to want to leave one terminal and go through the tube to the other side. So on this side, there is this device, which is just it's called a Tesla coil, and it just generates a very, very high voltage alternating current. But all you need to know is it's generating a lot of high voltage or high energy on the left-hand side. And then on the right-hand side of the tube, there's a wire over here that comes out, and it's connected to what's called the ground. I actually have it connected to a water pipe. And so that's going to provide a nice convenient pathway. So you can think of this as we're trying to generate a high energy electrical circuit, but one of the parts of the electrical circuit is that the electrons will have to travel through this tube. The thing about these tubes is that they really only work under vacuum, because right now there's too much gas, too much air in there. And if the electrons try to make it through, they're going to bump into the gas molecules, just like if you were trying to run through a really crowded room, you'd have difficulty getting to the other side no matter how much you wanted to get there. So I'm going to put this back in the holder. So now we've got the lights off, and we're going to start the high voltage source first, and then we'll start the vacuum pump. And once the vacuum starts, I want you to watch what happens inside the tube. So that's the high voltage source. You can see a little bit, it looks like sparking, but let's get the vacuum on. And there you go. You could kind of see the electrons made their way across the tube. And now we've got a complete circuit. The electrons are flowing, but the glow that you see is the electrons crashing into the molecules that are left inside the tube, and they are giving off light when those electrons fall back down to lower energy states. The color that you're seeing is due mostly to argon and the nitrogen that's left in the tube, and they kind of give this sort of purplish glow. A little bit of oxygen in there too. So the other thing that we want to show you is we're going to take a magnet, and remember how we talked about how a magnetic field can deflect an electrical beam, electric charge, so electricity and magnetism interact with each other. So we're going to hold a strong bar magnet. Now watch how the beam gets bent. When we put the magnet behind, you can see. I'm going to zoom in. So that's looking at the magnetic pole oriented one way. Now let's flip the magnet around, and you can see the deflection in the opposite direction. So depending upon the magnetic pole that is near the electron beam, then the beam deflects in a different direction. And so we can control the path of electrons with magnetic fields. And in fact, that's actually how electron microscopes work, by focusing electron beams. We talked about how this is the same way that old cathode ray tubes in TVs used to work. But here it's just a lot of fun. And we'll also show this as an example of how in the mass spectrometer, it doesn't only have to be electrons, but any charged particle will be affected by a magnetic field. And so if we have ions, we can also deflect their path using a magnetic field. All right, now for a couple fun things. We brought some fluorescent tubes, and we're going to hold one up. Let's bring a tube just close to it, and that also starts to glow. This is a UV lamp, for example, and it's not even connected to the circuit, but that high voltage coil is generating an invisible electric field around space around this tube. And so even without being connected directly, electrons are traveling and they're flowing inside that UV tube. And we can get that to glow. So invisible force field, they're real. We have a direct evidence that they exist. So here's a white fluorescent tube. That's pretty nice. And if we hold our hand in the middle of the tube, you can see that it kind of goes out because our body can act as a source of ground for the electrons to travel, make their pathway back to Earth. So that's kind of cool. So speaking of putting our hands on the tube, let's just put a hand on this tube right now and look neat. Let me zoom in a little bit. So this is not dangerous. The electrons definitely have a much stronger path through the tube to get down to the ground, but even your body can act as a source of a grounding point, and some of the electric field leaks off into your hand, but kind of fun to play with. So electrons are good times. All right, we got one more thing I want to show you. This is a little bit different version of the evacuated gas tube that we looked at before. This is called a bell jar, and it's sitting on a flat table. And the idea is that you can put this under vacuum. I can evacuate the air out of the jar, and you just saw the vacuum hose pop off, but that's what this is over here on the right. This little valve goes underneath and connects up to a hole in the bottom of the table there under the jar, and when we turn on that vacuum pump right there, it'll evacuate the air out. And so the experiment that I'm going to show you is that we're going to do the same thing we did with the tube, and that is to turn on the high voltage power supply. That is this Tesla coil, and it goes to a nail I drove into the top, and then the pathway is going to be down through the vacuum and out on the vacuum tube, and eventually this red cable is the ground cable sending the electrons back to the ground. So now we've turned the lights out, and we're going to start up the high voltage power supply, and then we'll start the vacuum pump. And it takes a little while. This vacuum chamber is a little bit bigger, but it's really cool to watch what happens as more and more of the air gets pumped out. So we have the high voltage at the top, and we can see electrons trying to make their way to the ground where it's connected at the bottom. Pretty cool. Give it some time. More and more air is being pumped out. So now the electrons are kind of traveling all over the place, trying to find their way through the crowded room of molecules to get down to the ground connection. But things are getting easier for them. Check that out. So now with a lot of the air gone, they can make, for the most part, a pretty direct path. So let's get in there and have some fun. Put your hand on there. So here's another alternative but weaker pathway to the ground, and some of the electrons will take them, and you can kind of see. They actually sell these things in novelty stores. They make them a little bit quieter. So I wonder if we held a magnet up to that, what effect that might have. Well, we can see a little bit of deflection. A little bit hard to tell whether it's just grounding out. Might be too far for that magnetic field. So that was pretty cool. So let's look at what happens when we bring some fluorescent tubes next to it. Boop. So again, that's an example of the invisible electrical field we're generating, and it can influence other things without even having to touch them. Yeah. I'd like to spend all day here, but probably should do some other chemistry. So here's another interesting thing that we found while making this video, is that the glass in that bell jar that we use for the vacuum chamber, actually, if it is hit with ultraviolet light, it'll fluoresce. And here's an ultraviolet light. I'll turn that on. This gives you this really nice green glow, and remember, UV light, you can kind of see it in the background, that's invisible kind of purple. And so it's exciting certain atoms in the mixture of that glass, and when they fall back down, when the electrons in those atoms fall back down the lower levels, they're giving off a different wavelength of light. This is called fluorescence, and so that's really cool. If you could be here live, it's even more spectacular, but yeah, fluorescent glass.